Welcome back to our favorite channel. Today we are going to discuss about internal combustion engine. That will be helpful to you, to the student of first year, as well as you can say student of third semester and fifth semester of mechanical engineering department. Hello friends, in this video we are going to discuss about basics related to internal combustion engine, which is widely used in automobile as well as in power generation sector. If you see, you can find here some newspaper articles related to local challenges, which include the pollution, which is a major cause for a local problem, and the major contribution in the pollution is by automobile vehicles. You can find here different headings related to BS3, BS4. You can say Swachh Bharat should include Swachh Air, even odd system, etc. So if you refer this newspaper article, you find that we are facing lot many local challenges. Out of that, one challenge is pollution, and the exhaust gases which are emitted by internal combustion engine is a cause for pollution. You can find here some other newspaper article that include scarcity of water, melting of glacier, rise in the temperature of the earth. These all are side effect of pollution. Also you can find here on the right side, India's first biofuel plane test a success. That is, we are discussing about alternate of fossil fuel in the article. So when we want to discuss about internal combustion engine, first we have to discuss what is meaning of engine. You can say engine means it convert any form of energy ultimately into electrical energy, or you can say ultimately into the power. There are different ways to classify engine. One by one we will go through that. So one of the way to classify the engine, that is according to the combustion of the fuel takes place. So in case of this forward cycle heat engine, we can classify the engine as external combustion engine or EC engine and internal combustion engine or IC engine. So in this syllabus we have to discuss only about internal combustion engine. So now we try to differentiate between EC engine and IC engine. So if we talk about EC engine, it is also known as external combustion engine, whereas this IC engine is known as internal combustion engine. So in case of this EC engine, external combustion engine, the combustion of the fuel takes place outside the engine cylinder, whereas in case of internal combustion engine, the combustion of the fuel takes place inside engine cylinder. So when the combustion of the fuel takes place outside engine cylinder, we can use any kind of fuel that include coal, coke, any waste available, etc. But in case of IC engine, we require costly fuel that you can say gasoline or petrol or diesel. In case of EC engine, the working fluid is steam, whereas in case of IC engine, the working fluid is fuel or air. The EC engine requires more time to start, whereas this IC engine is quickly start system. EC engines are bigger in size, less efficient and costlier. Compared to that, IC engines are smaller in size, efficient and cheaper. If we'll talk about EC engine, the example include the steam turbine and steam engine. Whereas in case of IC engine, the engine used in vehicles on the road, in aeroplane and in marine. These are some common examples related to internal combustion engine. So I hope friend this difference between EC engine and IC engine is clear to you. Now we'll go ahead. So now we have to discuss about internal combustion engine. So in case of internal combustion engine, the combustion of the fuel takes place inside the engine cylinder, and we have to discuss in detail about internal combustion engine, widely known as IC engine only. So friend, quickly if we talk about energy transformation, you can find that chemical energy of petrol or diesel or LPG or CNG, which is known as fossil fuel, that chemical energy of fossil fuel that will be converted into heat energy to mechanical energy, so the engine will run on the road. Your bus, truck, car or two-wheelers are moving on the road, and ultimately that mechanical energy is converted into electrical energy if we'll talk about DG set, that is diesel generator set. So ultimately what we have discussed, engine means it convert any form of energy ultimately into electrical energy. So here energy transformation include chemical energy to heat energy to mechanical energy to electrical energy. So now friend, we start to discuss about classification of IC engine. So what you have to do is, okay, you all are possessing some vehicle at your home. So what you have to do is, you also try to classify the vehicle which is available with you according to this classification. So now we start to classify the internal combustion engine. So you can say first way to classify the IC engine, that is according to the type of fuel used. That include dual fuel engine, petrol engine, diesel engine, gas engine and oil engine. In the similar way, if we go for second way to classify the IC engine, that include two-stroke engine and four-stroke engine. The next method to classify the IC engine, that is according to the type of thermodynamic cycle used. That includes Otto cycle, diesel cycle and dual cycle. The next way to classify the engine, that is according to the method of ignition. Either it is a spark ignition engine or it is known as SI engine, which is implemented in petrol engine. Whereas the method of ignition is compression ignition engine, or which is known as CI engine, and the example is diesel engine. The next way to classify the engine, that is according to the arrangement of the cylinder. So either it is a single cylinder engine or it is a multi-cylinder engine. So if it is a multi-cylinder engine having more than one cylinder, then again it is classified as V type of engine, opposed cylinder engine, inline engine, W engine, opposed piston engine, radial engine. The next way to classify the IC engine, that is according to the method of cooling of the cylinder. So one way is air cooled engine and second is liquid cooled engine. So these air cooled engines are generally observed in all lighter vehicles including two-wheelers, whereas the liquid cooled engines are observed in all the heavy duty vehicles. The next way to classify IC engine, that is according to the speed of engine. So either it is a low speed engine, medium speed engine or it is the high speed engine. Next is according to the application of engine, that include stationary engine, marine engine, portable engine, aero engine and automobile engine. The stationary engines are used in power plant, particularly as diesel power plant. The marine engine is used in ship. Aero engines are used in aeroplane and automobile engines used in all road vehicles. The another way to classify the engine, that is according to the method of governing. So either it is a quality governing, quantity governing engine or hit and miss type engine. So the quality governed engine include diesel engine, quantity governed engine include petrol engine, hit and miss governed engine include the gas engine, that is CNG or LPG operated engine. Next way to classify the engine, that is according to the valve arrangement. Either it is overhead valve engine, F heat type of engine and T heat type engine. The another way to classify an internal engine, that is according to the air intake process. So either it is a naturally aspirated system or it is a supercharged or turbocharged engine. So these are some of the way to classify the internal combustion engine. So what you have to do is, the vehicle which you purchase, you have to classify your vehicle according to this classification. Whether it is a 2-stroke engine or 4-stroke engine, petrol engine or diesel engine, air-cooled system or water-cooled system, quality governing or quantity governing, and so on. So easily you can remember this classification. Now we have to discuss about various parts of an internal combustion engine. And also we have to discuss function of some important components of an internal combustion engine. So friend, here you can see the details of an internal combustion engine. If we start from top, that is if we start from top right, you can find on the top exhaust valve is there, then you find outlet port is there, then you observe cylinder is there, then you observe piston ring is available, which is mounted definitely on the piston. Then piston pin is there, you can see small end bearing is there, the piston is represented, the piston is connected with the connecting rod, the another end of connecting rod is connected with a crank. You can also see big end bearing, the flywheel is also available, and crank pin is available. So the connecting rod is connected with the piston and with the crank with help of piston pin and crank pin. On the left side, if we discuss from top, you can see inlet valve, inlet manifold, you can see cam, you can observe crankcase, and you can see crankshaft. So these are some of the major components of internal combustion engine, where suction and exhaust valve will operate during suction and exhaust stroke, and they are allowing fresh charge to enter into the cylinder during suction stroke and exhaust gas to leave the system during exhaust stroke. The piston is reciprocating inside the engine cylinder, and the piston is connected with the crank by means of connecting rod. The crank shaft is rotating, and on the crankshaft flywheel is available. The flywheel is energy reservoir. It will store the energy when the excess energy is available, and the flywheel is supply the energy as and when energy is required to the engine. Now if we'll talk about the crank. So the crank that is connecting, or you can say the crank that is mounted on the crankshaft, and the connecting rod that is converting the rotary motion of the crank into reciprocating motion of the piston during starting of the engine. And once the engine will start, the connecting rod convert the reciprocating motion of the piston into rotary motion of the crank. So this is a very important function of connecting rod. We had discussed about the crank, we had discussed about the function of flywheel, we had discussed about suction and exhaust valve plus inlet and exhaust manifold. And the cylinder, you can say that is a component in which all the part what we had discussed, that is piston, piston pin, piston ring, connecting rod, all the things are available, and that is covered with crankcase. So friend, I hope that engine detail is very much clear to you. So now we will discuss the next part, that is we are going to discuss about working of 4-stroke IC engine and 2-stroke IC engine. So now friend, when we are talking about 4-stroke IC engine, that is either a 4-stroke petrol engine or it is a 4-stroke diesel engine. So when we are talking about 4-stroke, you can see all the 4 names that include suction stroke, compression stroke, expansion or power stroke, and exhaust stroke, that is in case of petrol engine. But it is not like that. Suction stroke is the first stroke and exhaust stroke is the last stroke. So when the engine will stop, either it is stop at end of the exhaust stroke or it is available at start of the suction stroke. It is nothing like that. Your engine may stop anytime. You can say there may be end of compression stroke, or you can say starting of exhaust stroke, or you can say end of suction stroke, and so on. So you can see here, these are 4 major strokes to complete one cycle. So when we are talking about the 4-stroke petrol engine, when there is end of all the 4 stroke, there is completion of one cycle, and during that time the crank will rotate 720 degree, means for completion of each stroke 180 degree revolution of crank is observed. So let us start with working of 4-stroke petrol engine. So friend, when we are talking about working of 4-stroke petrol engine, you can see here during the working of petrol engine, air plus petrol, that is called fuel, that is prepared in the carburetor and through suction manifold that will enter into the engine cylinder. So you can see from left side, first is a suction stroke, second figure that is of compression stroke, third is for power stroke, and last is for exhaust stroke. So we are moving from left to right, from suction stroke to exhaust stroke. So you can see during suction stroke, the piston is moving from TDC to BDC, that is piston is descending, the area above the piston is increasing, suction valve will be operated, and air plus petrol mixture which is prepared in the carburetor that will enter into the engine cylinder, and the entire cylinder is fully filled with air plus petrol mixture, that is called homogeneous mixture, at the end of suction stroke. So now at end of the suction stroke, the entire cylinder is fully filled with air plus petrol mixture. Now the second stroke will begin. So during second stroke, the piston is moving from BDC to TDC, that is the piston is ascending from bottom dead center to top dead center. So why it is called dead center? Because at TDC and at BDC the velocity of piston is 0. So now during compression stroke, the piston is moving from BDC to TDC, suction and exhaust both valves are closed, above the piston air plus petrol mixture is filled, and when the piston is ascending, the volume above the piston reduces, so the pressure and temperature of air plus petrol mixture is gone increasing, and before there is end of the compression stroke, there is occurrence of the spark. So the third stroke will start, that is called expansion or power stroke. So during third stroke, what we'll observe is above the piston very high pressure and high temperature of air plus petrol is available. There is occurrence of the spark. So immediately this petrol will catch the fire, the flame will generate, and the flame will propagate. So the fuel that will burn in presence of air, and it will form exhaust gases. So now these exhaust gases are available at very high pressure and temperature, and they are pushes the piston in downward direction. So this is a power stroke. During this stroke, the power is produced and the piston is forced to move from TDC to BDC. So at end of the power stroke, power is available that will be stored into the flywheel. The piston is at BDC, and above the piston only exhaust gases are available which contain 0% oxygen theoretically. So now the last stroke will start, that is called exhaust stroke. So during exhaust stroke, the piston start to ascend from BDC to TDC. Piston start to move in upward direction where only exhaust gases are available. So as the piston ascend, what happens is the exhaust gas pressure will start to increase. As the volume is decreased, exhaust valve will be operated and all the exhaust gases are entered into the environment via silencer or via muffler. So this is completion of one cycle. during which the piston is moving from TDC to BDC and BDC to TDC. The crank will complete 720-degree revolution. So the valve will be operated once during entire process, that is once during entire cycle. And you observe here is 4 stroke will be completed. So when there is completion of all the 4 stroke, there is completion of one cycle. So this is about working of 4-stroke petrol engine. Friends, I hope it is very much clear to you. So now friend, in the last slide we had discussed how the 4-stroke petrol engine will work. So in the similar way, we have to discuss about working of 4-stroke diesel engine. Again, you will observe here all the 4 strokes are similar to that of petrol engine. Then the question will come in our mind that what is the difference between working of 4-stroke petrol engine and 4-stroke diesel engine? So friend, we will discuss that part, but before discussion, we have to understand what is the working of 4-stroke diesel cycle. We had discussed that TDC, that means top dead center, and BDC, that is the bottom dead center. So at TDC and at BDC, the velocity of piston is 0. So it is known as dead center. So now we will quickly discuss about working of diesel engine. As you know that when we are discuss about diesel engine, there is a fuel pump and fuel injector assembly, plus you will observe air filter is available, that is not there in case of petrol engine. So this is one way how the petrol and diesel is differ, or you can say how the petrol engine and diesel engine differs from each other. So let us discuss about working part. So friend, now we have to discuss about working of 4-stroke diesel engine. So you can see from left to right, suction stroke, compression stroke, power stroke and exhaust stroke is there. So during suction stroke in case of diesel engine, the air from the atmosphere via air filter that will be entered into the engine cylinder when the piston descend from TDC to BDC and when suction valve will be operated. So at end of the suction stroke, the entire cylinder is fully filled with fresh air only, and the piston is available at BDC, that is at bottom dead center. Now for the compression stroke, like petrol engine, the piston ascends from BDC to TDC, volume above the piston reduces, so the pressure and temperature of air which is available is increased. So before completion of the compression stroke, the diesel is injected in atomized form. So friend, the question is there, what is meaning of atomized form? So atomized form means one droplet of diesel is converted into large amount of very small droplets, and so that for each and every minute droplet sufficient amount of air is available for complete combustion. Like if we talk about deodorant part or perfume part, we know that inside the bottle liquid is available, but when we press the knob, what we'll observe, it is atomized form of deodorant or it is atomized form of perfume. In the similar way, here also high pressure, high temperature air is available and the diesel is injected in atomized form. Because of high compression ratio, high pressure and temperature, this diesel will catch the fire and the air availability cause burning of diesel in presence of air. So we will move towards the power stroke, where now the high pressure, high temperature air is available and diesel is injected in atomized form. So the fuel will catch the fire, flame will generated and the flame will propagate. Now this flame and this exhaust gases will push the piston in downward direction, so the piston descend from TDC to BDC, and at end of the power stroke the piston is at BDC and now the entire cylinder is fully filled with exhaust gases. The power is produced and that will be stored into the flywheel. Now the last stroke, that is exhaust stroke, where the pistons start to move from BDC to TDC, above which only exhaust gases are available. So as the piston ascends, the volume is decreased and pressure is increased. So now the exhaust valve will be operated and all the exhaust gases will be thrown into the surrounding by means of, you can say, silencer or muffler. So to complete this entire cycle, the crank will rotate 720 degree. So for each stroke 180 degree revolution is observed. And this valve, that is inlet valve and exhaust valve, or you can say suction valve and exhaust valve, will operated once during the cycle. So friend, I hope that this working is very much clear to you, and also what is the difference between petrol engine and diesel engine, that is clear to you. So now we will move ahead with this clarity and with this clarification. You have to find out the name of vehicle in which 4-stroke diesel engine and 4-stroke petrol engine is used. In the similar way, you have to list out the example of 2-stroke petrol engine and 2-stroke diesel engine which is used on the road. So friend, now we will discuss about working of 2-stroke petrol engine and 2-stroke diesel engine. So friend, you should keep one thing very much clear to your mind, that in case of 2-stroke petrol engine, there is no valve. That is the first difference. Here instead of 2 valve, 3 different ports are available. Here instead of 4-stroke, here you will observe only 2 strokes are there. So now we'll start the working of 2-stroke petrol engine, and then after we'll discuss about working of 2-stroke diesel engine also. So friend, here you can see this sketch of working of 4-stroke petrol engine, where you can see definitely spark plug, carburetor is available, but instead of a valve, you can find here 3 ports are available. You can see one is exhaust port, one is inlet port, and one is transfer port. So this figure, you can say on the left side figure A is there, on the right side figure B is there. You can see on the piston deflector is available. We will discuss what is the function of deflector also. So you can see here figure number A, that is beginning of first stroke. So what you will observe here is, okay, at the beginning of the first stroke, you can see here the suction port is open. So when the suction port is open, the piston is covering the transfer port and exhaust port. So only the suction port is open. So the air plus petrol mixture which is prepared in the carburetor, that will enter into the crankcase. So at present you can see at bottom side of the piston, the air plus petrol mixture is entering into the crankcase, and the crankcase is filled with air plus petrol mixture. Now you can see the part B of the figure for first stroke. When the piston start to descend, the volume at bottom side of the piston will reduce. So the pressure of air plus petrol mixture which is filled at bottom side, that pressure and temperature will start to rise. At the same time, the volume above the piston increases. You can see the first stroke figure B, the volume above the piston that increases, so the pressure is decreases, and you can see the exhaust port is open. So if exhaust gas is available on the top side of the piston, that will leave the system. So what you will observe here is, in the first stroke at bottom side, the fresh charge is filled, and when the piston descend, the fresh charge, pressure and temperature will start to rise, and the fresh charge is ready to enter into the engine cylinder. That is, the fresh charge is ready to move from bottom of the piston to the above of the piston through the transfer port, and that is your first stroke. Now let us see what happens during the second stroke. You can see, friend, for the second stroke also two figures are available, figure C and D. So you can see in the figure C, the transfer port is covered, the piston is try to move in upward direction. So now you can see the fresh charge is entered, which is known to us. Okay, the fresh charge or air plus petrol mixture is available into the crankcase. Its pressure and temperature is increased, and now that will enter into the upper part of the system, and the combustion will complete and exhaust gas will again start to leave, and because of that you can say power stroke is performed. And you can see the figure number D, when the piston is moving in upward side, that is towards TDC, you can see exhaust stroke is covered, exhaust port is covered, transfer port is also covered, and you can find the air plus petrol mixture which is enter into the cylinder through transfer port. It compression process is completed, or the compression process is continuing, and before there is completion of compression process, the air plus petrol mixture which is above the piston, which is at higher pressure and temperature, there is occurrence of the spark. So the air plus petrol mixture which is available, that will catch the fire, flame will generate, flame will propagate, it will push the piston in downward direction, and hence what we had observed in the previous figure, that is possible, power stroke will be observed, the piston start to descend. So once the piston start to descend, you can say the exhaust port will open, exhaust gas will start to leave, and at the same time at the bottom side fresh charge is entering. So here in case of two-stroke engine, two strokes are performed at a time, like first compression and suction, and second is expansion and exhaust. So main two strokes are there, one is a compression stroke and one is the expansion or power stroke, but here suction stroke is performed simultaneously when the compression stroke is there, and there is no separate exhaust stroke is observed in case of two-stroke diesel engine. So the word scavenging is a very important word. The scavenging is the process to remove the exhaust gases from the engine cylinder after completion of power stroke is called scavenging process. So it is called a cleaning process, as there is no separate exhaust stroke in case of two-stroke engine. So to remove all the exhaust gases from the engine cylinder, we have to go with a scavenging process, and if scavenging efficiency is best, means best cleaning is observed. Otherwise the exhaust gases are remaining inside the engine cylinder, they will mix with the fresh charge, it will create the losses, it will reduce the efficiency of engine, and this is all is possible in case of two-stroke engine. So we have discussed about working of two-stroke petrol engine, and I hope this is very much clear to you. So what you can see is when there is completion of compression stroke and power stroke, there is completion of one cycle, and to complete this one cycle, this crank has to rotate by 360 degree, means for each stroke 180 degree will be observed. So you can tell that here in case of two-stroke engine, that is during every cycle, during every revolution, there is a power stroke. So theoretically the two-stroke engine is produced double power than four-stroke engine. So this is about difference between two-stroke engine and four-stroke engine. We had discussed about two-stroke petrol engine. Now we will discuss about working of two-stroke diesel engine. So now friend, in case of this two-stroke diesel engine, we are using diesel as a working fluid. Instead of this spark plug and carburetor, we will observe fuel pump, fuel injector and air filter assembly. Definitely there is a compression stroke and there is the power stroke. So now we will try to differentiate between the working of petrol engine and diesel engine. So try to concentrate on working of diesel engine, and now we will discuss about working of diesel engine. So friend, here in case of diesel engine, on the top you can see top left figure number A, you will observe fuel injector is there. So what happens, you can see at present is when the piston start to descend, you can see already the inlet port is open, air from the atmosphere via filter is enter into the crankcase, and the entire crankcase is fully filled with air only, and now the bottom side of the engine is filled with air. Upper side you can see that is end of the stroke and the piston start to descend. You can see that is end of the compression stroke and the piston is moving in the downward direction, that is towards BDC side. So now you can see the figure B of first stroke, where you will observe the piston is continuously descending in the downward direction. Because of that, the volume above the piston is increasing. The exhaust gases will push the piston in downward direction, that is a power stroke, and as soon as there is opening of the exhaust port, all the exhaust gases will start to leave the engine cylinder, that is on the top side. What you can see on the bottom side is when the piston is descending, the volume bottom side of the piston is decreasing. So the pressure of air which is available, that start to increase. So when the pressure of air is increased, temperature of that same air is also increases. And you can see in the figure of first stroke B, where the fresh air will start to enter into the engine cylinder through the transfer port. So now exhaust gas are leaving from one side and the fresh charge start to enter from opposite side. So at one side exhaust is completing and other side the suction is cleaning process is starting. You can see the second stroke where you will observe the exhaust gases are leaving and fresh charge is entering from another side. So the scavenging process is completed. You can find exhaust port as well as this suction port is open. So exhaust gases are leaving from top side, air is entering from bottom side, and the air which is available above the piston, which is shown in figure number D, that start to compress. So the pressure and temperature of air is increased, and before completion of compression stroke, before the piston will reach to BDC, the diesel is injected in atomized form. So because of high pressure and temperature, it will burn, it will catch the fire, flame will propagate, flame will push the piston in downward direction, and the diesel will burn in presence of air. It will form the exhaust gases. These exhaust gases are pushing the piston in downward direction, that is your power stroke, and the piston start to descend. As soon as there is opening of exhaust port, the exhaust gas start to leave, and that is end of the second stroke. So friends, mainly here also two strokes are available. One is compression stroke and one is expansion stroke. So again, like previous case, here also to complete one cycle, the crank will rotate 360 degree. So for each stroke 180 degree will observe, and during this entire cycle, the power stroke or is observed once, means theoretically the power produced by two-stroke diesel engine is double than that of four-stroke engine. And friends, one important thing which you can observe here is, if the scavenging is not proper here, or if scavenging efficiency is less here, then the exhaust gases will mix with air only, and you will observe loss of air. And if there is a loss of air, still we can say that air is available at free of cost, and this loss can be negligible if we will consider this kind of thing. Otherwise, under no circumstances it is desirable that the exhaust gas will mix with the fresh air. So friends, we had discussed about working of four-stroke petrol engine, four-stroke diesel engine, two-stroke petrol engine, and two-stroke diesel engine. So you try to repeat the same video again and you try to understand the working of 4-stroke petrol engine, 4-stroke diesel engine, 2-stroke petrol engine and 2-stroke diesel engine. Now we try to differentiate between the 2-stroke engine and 4-stroke engine, as well as 4-stroke petrol engine and 4-stroke diesel engine with different aspect. Means we try to differentiate among IC engine with different parameters. So friend, now we have to discuss about comparison between, you can say, 4-stroke and 2-stroke cycle engines. So here you can find some difference between 2-stroke engine and 4-stroke engine with different aspects. Like first aspect we can see is completion of cycle. Next is requirement of flywheel, that is either a lighter flywheel or heavier flywheel is required. Then we can talk about cooling and lubrication part, and we can say that valve and valve mechanism. So friend, you can see here the according to different aspect what is the difference in the 4-stroke engine and 2-stroke IC engine, that is shown here. So you refer that, and accordingly if the question is asked in the exam, you can write what is the difference. So here the 4 aspects are shown that include completion of cycle, flywheel requirement, cooling and lubrication requirement, as well as valve and valve mechanism. In the similar way, if we'll go with the more differentiation or more difference between 2-stroke and 4-stroke engine, we can say that other aspects include power produced for the same size of engine, that is a 4-stroke IC engine or 2-stroke IC engine, volumetric efficiency in case of both the type of engine, thermal and part load efficiency for 4-stroke and 2-stroke IC engine, initial cost of 2-stroke and 4-stroke IC engine, and application part. Friend, I told in the previous slide that you have to prepare a list where you have to write where the 2-stroke engines are used and where the 4-stroke engines are used. Same thing is mentioned here, what are the application of 2-stroke cycle engine and 4-stroke cycle engine. So friend, refer this slide, prepare this difference, that will be helpful to you for your competitive examination as well as for your regular examination. Now we again try to differentiate between the 4-stroke petrol engine and different 2-stroke diesel engine with different aspects. So friend, now we have to discuss again about comparison of petrol engine and diesel engine, that is a 4-stroke engine and 2-stroke engine. The aspects given here are thermodynamic cycle, you can say fuel used, air fuel ratio, combustion, that is combustion method, operating pressure, and control of power, that is different ways, different aspects are given for 4-stroke engine and for 2-stroke engine. So just refer the comparison which is given for different aspects and you have to prepare accordingly. The other aspect includes compression ratio, fuel supply, operating pressure, operating speed, calorific value, running cost, maintenance cost, exhaust temperature, power requirement, that is high power, starting, distribution of fuel, weight per unit power, and last is initial capital cost. So these are some of the aspects through which you can compare the petrol engine and diesel engine, that is 2-stroke and 4-stroke engine. So refer all these aspects and compare the 4-stroke engine and 2-stroke cycle engine. The last two aspects that include the noise and lubrication and application part for 4-stroke cycle engine and 2-stroke cycle engine. So friend, when you go with all this difference, Definitely you can understand the working, application and comparison of two-stroke and four-stroke IC engine with almost 20 different aspects. So friend, in this slide you will observe the comparison of petrol engine and diesel engine. You can say either it is a four-stroke petrol engine and four-stroke diesel engine, or you can say it is a two-stroke petrol engine and two-stroke diesel engine. So here you will observe the difference between petrol engine and diesel engine, that include, you can say, require different component like a spark plug is there in one case. In case in diesel engine the injector is there, that is fuel injector, fuel pump, air filter, thermal efficiency, running cost, weight, fuel used, all different parameters are shown here, and accordingly the comparison is given. So refer this comparison, that will be helpful to you. So friend, in this video we have discussed in general about engine, classification of engine, working of four-stroke petrol engine, four-stroke diesel engine, two-stroke petrol engine, two-stroke diesel engine, and comparison of petrol engine as well as diesel engine, plus comparison of four-stroke engine and two-stroke engine with different aspect. So in general, what is the fundamental requirement for internal combustion engine, that is covered here. So if you like this channel, if you like this video, do not forget to subscribe this channel for new updates, as well as share this channel among your friends. Have a nice day. Thank you.